From the Gregson Centre volunteers, welcome to our first community podcast. I'm Emma Townley and this is Radio Gregson. Today we have a special guest, Professor Jim Wild from Lancaster University, and a story by Michael Ford of Lancaster Law. In this episode, we're joined by Professor Jim Wild, Professor of Space Physics at Lancaster University, and he's going to talk to us about the Northern Lights. Hi Jim, welcome to the podcast.
Hello there.
Do you want to tell us a little bit more about yourself?
So I'm Jim Wild, I'm a Professor of Space Physics, and my background is I do research studying the links between the Earth, the Sun and some of the other planets. And that's a little bit more than just the heat and the light that we know about that comes from the sun. And ultimately, I get to study all the fun stuff that leads to things like the Northern Lights, the Aurora Borealis. So that's a really nice starter at dinner parties when people say, "What do you do?"
So this year, many of us had the amazing experience of seeing the Northern Lights from outside our homes. Could you tell us what are the Northern Lights?
So the Northern Lights are a natural phenomenon that occur in the upper atmosphere of our planet and actually other planets in the solar system. And they are caused by electrically charged high-energy particles from the space environment around our planet raining down into the upper atmosphere and causing the atmosphere to glow. They've got a long-lived legacy of myths and folklore around the edge of the Arctic Circle, because normally you'd see these things around the edge of the Arctic Circle when the sky is clear and it's dark. You get these beautiful patterns of light in the night sky, typically greens and reds of sort of really ghostly, dancing, shifting lights in the night sky. So the cultures around the edge of the Arctic Circle have, these things have been there always, and so these cultures have grown up building the Northern Lights into their folklores, into their stories, in the same way where here in the UK there are stories and folklores and legends about the changing of the seasons and what happens when it's harvest time. Well, if you were a nomadic or a hunter-gatherer group of people living at the edge of the Arctic Circle, then at night times the Northern Lights would come out, so there's loads of great legends about what we're looking at. We now know that these lights in the sky, these shimmering, ghostly, dancing lights in the sky are caused by particles coming from space. A lot of the energy that powers that is coming from solar activity. So really what we're seeing is the effects of living quite close to a star, electromagnetic effects on the surface of the sun, firing things out from the sun towards the Earth, cause the upper atmosphere to glow. It's just that we're not very used to seeing them here in the UK. They're normally much further away at the edge of the Arctic Circle.
What advice do you have for people trying to see the lights?
So it kind of falls into two camps. If you're really desperate to see the Northern Lights, then a lot of people will try and go to where the Northern Lights normally are. If it's on someone's bucket list, you can often find there's holidays which can take you to high latitudes in the Northern Hemisphere. And actually, in the Southern Hemisphere, you can go to Antarctica and try and see it. That you get the Northern and the Southern Lights, the Aurora Australis and the Aurora Borealis. But if you're, like most people, thinking, well, I'm not sure I want to go to the Arctic and pay a lot of money to do that, how might I see them from the UK? Then what we really need is, you need a bit of luck. We need solar activity to be quite high, because when solar activity is much greater than normal, it pushes the Northern Lights from their usual location up in the sort of Arctic latitudes down to the UK. So you need a bit of luck, and without that, you're not really going to see anything. Most of the time, we'd normally say that the Northern Lights are visible a few times a year from the UK. Quite often that means higher latitudes in Scotland, in the northern parts of the UK. And it can be a real challenge. You do get aurora chasers who go and spend a lot of time sitting on dark mountain tops or beaches or whatever, looking at the north. However, we need every now and again that activity, that solar activity, to push the Northern Lights a bit further south. And right now, we're a good time to do that because the sun has a natural cycle of activity. Just like the rhythms of the changing seasons in the weather here on Earth, the sun goes through an activity cycle. And it goes from being very quiet in terms of its outputs and its magnetic activity to very active to quiet again on about an 11-year timescale. And so 2024, 2025 is going to be the peak of the current activity cycle. And when the sun is more active, it basically throws out more material into space. And it's those sort of explosions of materials out into space arriving at the Earth, which are what push the Northern Lights down to lower latitudes. So we really need the sun to be kind of doing its thing. And so the technical language is we need coronal mass ejections, which is a great phrase. So the corona is the sun's upper atmosphere, and we need some material, some mass to be ejected. Those take several days to cross interplanetary space and then arrive at the Earth. So because these get fired off in all directions from the sun, they can go anywhere in the solar system, but every now and again one gets fired towards Earth by chance. And when that arrives at Earth, that really activates all the processes in the regions around space that cause extra material to rain into the upper atmosphere, and that means the northern lights come further south and they come and visit us in the UK, which is lovely to see. And those solar explosions, these coronal mass ejections, tend to happen more commonly at the solar maximum period. So the reason we've had the northern lights a couple of times in the UK, spring and autumn 2024, is because the sun is at the peak of its activity, and it's going to stay this active, for the next year or so before it starts to trend downwards again over the next 5 or 6 years to its minimum in solar activity. So if you want to see the northern lights here in the UK, you need a bit of luck. You need the sun to be doing its thing, but you also need to be able to get somewhere where you'll be able to see the sky well. So first of all, you need to have good weather, which, as we know here in the UK, can be a bit of a challenge. And you also need to be able to see the northern sky usually, So we were very lucky. There were some very impressive displays this year where the northern lights were actually almost overhead. I mean, here in Lancaster, I could actually look up and slightly to the south to see the northern lights. And that's because they really were a very long way south of where they usually are. Most auroral displays you see from the UK, if you go and look on social media, they're from Scotland or the north coast of Norfolk somewhere, or north coast of Wales, or the Lake District, these lovely dark sites. Most of those displays tend to be sort of quite low in the sky on the northern horizon. They're much more common, those kind of displays here in the UK. So ideally, somewhere dark, somewhere with good weather and a view of the northern horizon are what you're really wanting. But then it's a case of you just need the sun to do its thing. There are some ways you can help. Here at Lancaster, we run a project called the Aurora Watch. So basically, we send out real-time social media alerts when solar activity is high enough that we think the northern lights are going to be seen in the UK. And that's made a big difference, I think, because people now get a bit of an alert. It tips the odds in their favour, because normally as a species, modern British people tend to go indoors in the evening in winter months, pull the curtains and turn the TV on. And so you might not be looking at the night sky. So having something on your phone that says it might be worth going outside is, I think, a big advantage as well.
I was going to ask, how would you find out when and where they're going to be visible? So is that an app, just on social media?
Aurora Watch we run as an app. You can get it as an app for iPhones, or you can subscribe on Twitter, now X, and Facebook, and you can get the alerts. They're all free. And what they do is they're not really forecasts. They're it's a funny word. They're more like nowcasts. And so they tell you what's going on right now. Forecasting the northern lights is actually very difficult to do still. It's a science that's quite in its infancy. But when we see one of these, for example, one of these coronal mass ejections arrive at the Earth from the sun, we can see the Earth's magnetic field sort of ring and wobble in response to the impact of this material coming in. And the electromagnetic effects that then drive these lights in the sky, we can sense from the ground. And so what we do is we have instruments that measure the Earth's magnetic field and see it wobble around and be disturbed. And when we see certain patterns of behaviour, we send out that alert. Now, as an end user, you don't need to understand all of that physics. But what it means is you get an alert, either an amber alert or a red alert, saying there's a good chance of seeing something now. So it's quite sort of easy to understand. Now, of course, that alert might come and you look outside and it's cloudy. And that's kind of game over, because the clouds tend to be about 10 kilometres above our heads, 10,000 metres. And the aurora are typically 100 kilometres and higher. So if it's cloudy, then you're not going to see anything. But those alerts can give people a real clue. And actually, I think a question people ask me a lot at the moment is, how come we had 2 great displays of the Northern Lights this year visible from much of the UK? There was one in May and there was one in October of 2024. And people saying, why are the Northern Lights more visible now? Has something changed? And actually, I think social media plays an enormous part in that. So partly it's because we're at the current maximum of solar activity. So we'd expect the Northern Lights to be visible from the UK more now than other years around now. Sort of, so in 5 years' time, we'd expect the likelihood to be a bit less. And it will peak again about another 5 years after that. So we're in a kind of sweet spot for solar activity, which is great. There were a couple of other things, though, that really helped people see the Northern Lights. One of which was the timing. It just so happens that on both those occasions in May and October this year, that the explosion of material from the sun arrived at the Earth in the early evening in the UK. So it just happened to arrive at about 7, 8, 9 o'clock. And so everything kicked off in those nighttime hours when it was dark, but everyone was still awake. Had that occurred at 3 a.m, everyone would have been in bed, and no one would have seen it, because and the pictures of it wouldn't have happened because everyone would have just been asleep. Both those nights, they were clear nights over the UK, so it was cloud free again. So we were very lucky. But also, what happens now is the social media effect kicks in. So people like us, Aurora Watch, we're sending out alerts. But people can see on their social media feed that someone just up the road in Kendal or in Blackpool has just seen the Northern Lights. And it's, oh, wow, if they're seeing it there, I might sit here. And you go outside and then you see something and you take a picture with your camera phone. And actually, modern camera phones are very sensitive to the colours of light that the aurora emit. So even if it's a bit faint for your eye to see, if you hold up your camera, you can see it on the screen. And then people start taking great pictures and then they share them, and it goes viral very quickly. So people are alerted and can check to see if Northern Lights are occurring much more easily. So all these things kind of come together. And this year we just had a couple of nights where we hit the sweet spot of all those things aligning, and we got these great displays of the Northern Lights.
And so what is your favourite, or what do you find most interesting about studying the Northern Lights or space physics? So
I was a child of the late 70s and early 1980s. So I grew up just being a bit of a space nerd, loving space. So Star Wars, Star Trek. I'm a pretty typical physicist. Lots of Lego space toys. I remember watching space shuttle launches on John Craven's Newsround as a child, and I've always been hugely interested in space. And one thing I like about space research in terms of the Northern Lights, it's very interesting. People are generally they want to talk to you about what are the Northern Lights. We're having the conversation now. Where do they come from? Why are they here? That's fascinating. I get to work with experiments both on the surface of the Earth, looking up at the Northern Lights, for example, but also orbiting the Earth, so satellites looking at the space environment. And virtually everything I've said can be translated into other planets. So there are aurora, there's northern and southern lights on the gas giants, on Jupiter and Saturn. We know that there are different kinds of auroras, much fainter on Mars. Potentially there are some auroral emissions on Mercury. So looking around the solar system, we can see the Northern Lights are actually quite ubiquitous. And usually the Northern Lights are coming around because of an interaction between the space environment and a planet's atmosphere and magnetic field. So we tend to see the Northern Lights on planets with magnetic fields and atmospheres. And as astronomers who look through telescopes out into the distant universe are starting to discover more and more planets around different stars, it may well be that information about the Northern and Southern Lights on those planets will reveal information about how the atmosphere is configured and how habitable they are, because it tells you you've got a strong magnetic field, which is probably a condition for life. Our planet has a force field, a bit like Star Trek and the Starship Enterprise. That magnetic field of the Earth actually acts as a force field, a shield that shields us from solar particles. So the worst of space weather goes past us, and our atmosphere and the surface of the planet is shielded by this magnetic force field. Well, so we probably want to find other planets that have magnetic fields that shield their surfaces and their atmospheres from the worst of space weather, because if the planetary environment is going to be stable over long periods for life to evolve, that's what you're going to need. So from pretty lights in the night sky to how it can impact a power grid or your satellite communications to will a planet be stable enough to support the evolution of life, the Northern Lights and space weather cut through all those things. So it's really exciting.